At Long Now, one of the things we say is that we're striving to be good ancestors. It's part of the long view that what we want to do for future generations, for people that are kids now, for their kids and on, is to give them more options, more possibilities. That's one of the things that we're doing. And in all sorts of ways, if you're at a fork in the road, which one gives more choices to the future inhabitants? And we don't talk about it a lot this way, but this networked information technology world that we're living in now is an amazing intergenerational project. And so the backbones, the protocols, programming languages, these are infrastructure and building blocks of what we're making today and what will be made tomorrow. And that goes across the hardware, the software, the concepts, the UI concepts, the content, the data, all of those things. And if you are working on technology today, as much as there may be pressure to work on it for the short-term reasons and business goals that are in front of you, you also need to think that these are precedents that are being set, tools that will be available to then be extended into the future. And so our speaker tonight, Brian Behlendorf, is in a really interesting way his own ancestor. It's not often that I can honestly say that probably everyone in this room has, if you've been on the web today, you have run code that Brian had an ancestral hand in. With the Apache web server and with not only the software but the organizations that have come out, both the Apache Foundation, the Open Source Initiative, Mozilla Foundation, and EFF, which he continues to sit on the boards of. We're getting to speak to an architect who's also swung a hammer on the job, and we are all benefiting, and he is benefiting as he's continuing in this layered way that we do with technologies to build on top of the foundations, literally and figuratively, that have come before. So I think as we go into this talk tonight, there's a lot of hype around, as there always is, around technology buzzwords. But I think the right way to approach tonight's conversation is with a bit of awe and a bit of gravity. That we've already built amazing things. It was 30 years ago that Tim Berners-Lee had the idea in 1988 that would then be published as the first technology and documentation in '89 for the web. And that's when that starts. So what's being done tonight and what's going to be released next year, what we've done so far is awe-inspiring, and it should only increase our ambition for what we can do into the future. And with that, let's ask those questions to someone who ought to know, Mr. Brian Behlendorf.
Thank you. Thanks. Cool. Well, it's really an honor to speak here. There are some fellow good ancestors in the room, so I appreciate them coming out to listen to this. And my wife's here as well, who's also given me a reason to be a good ancestor because we have a 3-year-old daughter, and that's just, it really does sharpen your focus on thinking about the long term and trying to, do the Burning Man thing of leave it cleaner than you found it, right? Not just leave no trace. Yeah, and a lot of that has motivated kind of my thinking around why I'm involved in this space in the first place. I think, like many of you, you probably first heard about Bitcoin around the time that it first appeared on the kind of doc in 2008 was when Satoshi's first paper came out. And I think like many of you at that point, I was a little concerned that this internet thing that we had built on top of was re-centralizing in a way. I mean, it was never really totally decentralized, and we can have an interesting conversation during the Q&A about the word decentralization. But it was certainly a place that felt flatter, right? It was a place where where you could run your own mail server, you could run your own website, you could run a lot of your own software. You didn't have to, but the fact that you could was an incredibly liberating kind of thing, right? And there was just enough decentralization on the internet that it was spawned. It was a place where a lot of new businesses could be formed. And I don't know if this makes me a good ancestor or not, but I, along with some others here, were complicit in putting the first ad banner on the web. And I tell people I've been atoning for it ever since. But even in those days, it felt like the internet was this wide open frontier that by 2008, it didn't quite feel so much like a frontier. It felt a little more like things were organizing to get back to perhaps what Thomas J. Watson, who was the founder of IBM, said, which was maybe there's only a market for actually 5 of these computers in the world, right? It turned out that they would be, Microsoft, Amazon, Apple, et cetera. And so at that point, the launch of Bitcoin kind of felt like there were a number of other projects along these lines that were about a set of developers going, well, can we just reinvent the underlying protocols to not have this, centralizing network effect, right? Is there a way that we can make it cheap again and create a financial incentive and a protocol that made it so that you could host things in a decentralized way and didn't have to worry about these centers of gravity forming out there in the world? And possibly idealistic. I resonated with it, but I had some issues with it too. I had some issues with the idea of proof of work serving as the fundamental basis for how this works. And I can go into it in a bit, but proof of work is basically burning CPU power to run a lottery to figure out who puts the next link in a chain, which for a lot of people, as they start looking at this, makes you go, I'm not so sure I want to get into this. I kind of call it the mercury mining of our generation, right? In that it's cool, technically, but also kind of icky once you get into it, and certainly can leave a toxic legacy. What I also was concerned about was whether a speculative financial instrument really was the right way to build the Web 3.0, right? Was there a risk that this would be gamed the way that financial markets have always been gamed, and we would find a whole new set of empires being built out of thin air, fairly or unfairly, right? Because the internet never felt that way. Internet technologies and protocols, you'd release a piece of software, the 1,000th person to adopt it didn't benefit from it less than the first person to adopt it, right? In fact, they probably benefited more. It was a snowball effect that grew and grew. And so I stayed kind of away from Bitcoin, much to, again, our family's detriment. Did not invest early on in Bitcoin or any of the others, but kept my eye on it. And it was when I kind of realized that there was perhaps another take on it, which was to look at the technology underneath cryptocurrencies to try to understand, was there something innovative and unique there, and a way to detach it from some of these things that felt weird, that I decided to jump in. And I'm not going to make these 30 minutes that I'm going to try to talk, try to keep it limited to a pitch for what I do, but just by way of biography. So I am executive director of something called Hyperledger, which is a blockchain technology project hosted by the Linux Foundation. Now, the Linux Foundation has been around for about 15 years now, trying to build open source communities in all sorts of different spaces, long beyond just the Linux operating system where it started, now in cloud computing, software-defined networking, lots of things that feel like plumbing, but things that start to get into the real world. So we just launched an energy-related project, for example, for software that runs the grid. Lots more to say about that. It's kind of more of a kind of business consortium kind of model, but it provides the resources to fund a program office that acts kind of like an air traffic control network for contributors who show up and want to build open source code. And so at Hyperledger, we're the home for hundreds of developers working for hundreds of different companies working together on common infrastructure for blockchain technologies, some of which I'll hint at in the presentation. And if you're interested, hyperledger.org, lots more to talk about there. But I really just wanted to leave you with today was perhaps a different way of looking at what this blockchain revolution means, what this technology means, a different conceptual frame. And then actually this is nicely paired with Juan Bennett's thing on Monday, because Juan, I think, is in some ways I've been accused of making blockchain boring because I try to demystify it a bit and make it less kind of magic pixie dust, and hopefully you'll appreciate that. Juan does that too. He writes software. IPFS is an amazing series of different technologies, and he is truly thinking about the 20-year kind of horizon and how do we reboot a lot of fundamental architectures of how the internet works. I agree with about 2/3 of it, and 1/3 seems a little wacky, but I think that's right. I think you want that kind of balance. So I really encourage you to go see his talk on Monday. So to dive right in, and this is where Otto's picture came from, but hopefully this helps frame it for you. If there was one picture that I could leave you with here about what blockchain technology is, at least the way that I define it, the way a lot of people who I know define it, is that there's two underlying innovations, both of which seem fairly banal when considered kind of by themselves, but I think in combination really build something cool. So the first is a new approach to databases called a distributed ledger. And we've had databases since the beginning of computing, right? Databases are nothing magical. And we've actually gotten really good at building big centralized databases, things that scale to the order of hundreds of millions of transactions a second, reads, infinite numbers of reads, right? Like things at the scale of a Twitter or a Facebook, with all sorts of dials for consistency, for liveness, for all these kinds of technical issues. But we've gotten good at that. What we have not gotten really good at until we've returned to some of these technologies is a decentralized database. And a decentralized database is one that where what's in the database and what's kept consistent is not governed or limited or processed by a central actor, but is instead shared amongst a network of potentially mutually distrusting parties. Right? And so the graphic here that Otto drew was really my attempt and the Swiss artist's attempt, processing my attempt, to show the distinction between these two kinds of, I don't even want to call them networks because it's above the layer of the network, right? On the right, sorry, does anyone here work for Uber? I don't want to make you feel uncomfortable or anything like that, and so I'm sorry, but frankly, if one were to draw the architecture of Uber and its connections to its user base, right? It would be the drawing on the left, right? Uber runs a set of servers that handle requests from mobile apps, from their web front end, et cetera, and puts them at the center of that universe. And they do a pretty good job. I don't want to get into controversies about Uber this or that or whatever, but in terms of delivering a service that people can use, centralization actually works. But it does put them in the driver's seat, literally, no pun intended, of defining how the system works, how it evolves, and also what is the state of accounts between with drivers, with passengers. If it turns out somebody needs to be refunded, they can do that immediately. That's fine. But they could all, there's also the risk that they could play God, right? That they can change balances, that they could, run things in a way that if the consumers noticed it, great, and they'd be able to call them on it. But and that might be something that we tolerate for a ride-sharing app, but we might not tolerate if we're talking about a network of banks wanting to send money to each other. Having somebody at the center that can play God presents a level of risk that's hard to quantify, but is very real. And so for a lot of reasons, we want to build networks and application layers and data layers that actually try to avoid putting anybody in the center to play God. And that's the picture on the right. And the picture on the right, or on the screen here, the picture on the left, is intended to show really a network of independent actors, right, connected to each other, right, talking to each other, sharing, transmitting transactions to each other, but ultimately coming to a consistent state and a consistent history of the events that happened. That's what these lines here are coming off and up. That's what those boxes are going off to the left. Clearly, art skills are not one of my strong points. But the point here is that everybody on that network has the same picture, the same story of what happened, right? And when you do that, you end up with an interesting property. No one can go back in time and change an entry in that ledger to mean something else, right? And that is enforced not just by social convention. This is enforced using cryptography on each link from one to the next, where the previous link is signed and it becomes part of the signature for the next one, becomes a signature for the next one. And so if you try to change something in the middle, the signatures don't check out anymore, right? So in this way, the history can be verified simply by comparing the last signature in that chain of transactions, that chain of blocks, which is why it's called a blockchain. The interesting question is, well, how does that network come to an agreement on what is the next entry in that chain, right? When you're talking about a very small network and a very slow rate of transactions, it's pretty easy, right? Somebody says, I've got a clicker. Somebody else says, I've got a glass of water, and everybody can hear what everyone is saying. But what if there's a lot of nodes on the network, and there's a lot of proposed transactions, and things get very buzzy? Well, this is why people care quite a bit in blockchain technology about these things called consensus mechanisms. And you might have heard of the term Byzantine fault tolerance. You might have heard about Paxos. These are all names for algorithms and approaches to trying to resolve that problem of who gets to put the next link in the chain. And there's not one answer to this. There's algorithms that work better if you're talking about thousands of nodes, but only a slow number of transactions per second. Others that work better if you're talking about 10 nodes and thousands of transactions a second. But you want a set of options. Now, proof of work, like I mentioned in Bitcoin, is just one of those. And proof of work is essentially a lottery that says one of these networks wins the prize by trying to compute this special kind of like answer to a question that everyone can quickly verify, and so they know, okay, node number 56 did win that, and so whichever block they accept is good, right? But there are a lot of other approaches to it. And kind of coming to that realization that there's other approaches is one thing that let me jump in to the blockchain technology and realize you could build something interesting. What's also interesting about this question of how does a network come to an agreement about that series of transactions is, well, who is in the network? Right, and very much like it's very much like who is in this room right now. Pretend you all are nodes on a blockchain network, right? All of you are individual, kind of like companies or servers or whatever kind of metaphor you want to use. And let's say all of you kind of mutually distrust each other just enough to want to have your own copy of the ledger, right? Well, when one person's standing up on stage, it's obviously very easy. When somebody throws out a question from the room, it's obviously very easy. But if we start getting chatty, we need some way to resolve that. And that's what consensus mechanisms are all about. Proof of work is one way, but there are plenty of others. And if we have a bounded finite space like we have here in this room, where there's somebody at the door kind of like keeping tabs on who can come in, it's much easier for us to have a consensus mechanism based essentially on one person, one vote, rather than trying to run this kind of lottery. And that's really the big difference between what you would call permissioned ledgers, permissioned blockchains, which is everybody in this room kind of, who can be one person, one vote, versus unpermissioned ledgers, which is we're out on the street, we have thousands of people walking by, no one really knows each other, but we use, kind of a lottery style kind of system to be able to figure it all out. So that's distributed ledgers. The second big picture is, the second part of that is what the term has been used as smart contracts, and people kind of wince when they say that because the term smart anything tends to, should be replaced by hackable, in my opinion. Smart home, hackable home, smart car, hackable car. But the point of a smart contract is this. You can write a script that you push out to the entirety of the network. Right? And this is a piece of software that'll sit there, and based on some trigger, it could be a certain time, it could be when it sees a certain event, will then run everywhere on the network. And it'll execute. It'll either check, hey, has the temperature in Sacramento been 100 degrees Fahrenheit for during the growing season, right? Then pay out this insurance contract for a farmer, right? Or if these other 3 steps in some business process have been completed, then automatically assume that a 4th one can be done, checklist style, right? Now, this seems odd. Why would you push this out to all the nodes in the network? Well, in doing that, you end up writing software that doesn't live in just one place. It lives on the network. And when it all runs, the network comes to a consensus, a convergence on a common answer. And when that consensus happens, it gets written to the ledger. So this is useful to avoid a scenario where there's, in like, say, an insurance agreement where there's counterparty risk, right? You sign an agreement with a company to pay you, if your farm suffers from drought, defined as temperature in Sacramento, but they don't pay because it turns out they're not State Farm. They are some 2-bit kind of insurance fly-by-night that disappeared. Well, this is a way, if this script runs and it says, okay, automatically now there was a drought, transfer $1,000 or $10,000 to the farmer's account, then the farmer knows that they can get paid, even if the company that was behind it went out of business or couldn't be contacted or couldn't fulfill their commitments. And so there's lots of different financial products that can be modeled as smart contracts. There's lots of other business processes that could be modeled as smart contracts. But it's a way to get us out of the tyranny of the centralized server when it comes to not just storing of data, but processing of logic. And that's really cool. So those are the two fundamental premises. Now you notice in this whole conversation I've been able to describe it without talking about you need Bitcoin here or you need Ethereum there. These are interesting applications of those two principles. And in particular, I'm fascinated by the Ethereum community's idea of using a currency not just to as a way to send money around to different people, but also to drive as what they call gas, these smart contracts, right? Some really advanced work being done there. Really fascinating. But there's also a lot of complexity that tries to come, especially from dealing with big public anonymous networks like the unpermissioned networks try to do. And so a lot of the examples that I'll point to here actually don't even require running things on top of such a complex underlying infrastructure. So at Hyperledger, and a lot of the kind of enterprise kind of blockchain stuff that we've done, we've kind of seen three main kind of categories of different blockchain deployments, starting now, but certainly edge cases outside of this. One of those is in financial services, right? So almost anything that involves a ledger in financial services is ripe for this, whether it's bank wires, whether it's sending money between banks, whether it's collateral trades, insurance products, know your customer and anti-money laundering kinds of checks that are done when people open an account, all those sorts of things. Supply chains, I'll show you an example soon, and surprisingly in healthcare, which I can talk more about examples in the Q&A. But what would make up a really good set of use cases that you would apply to something like this? And I'm sorry if this is small, I'll try to read it in the back, but this is cribbed from the World Economic Forum's report on blockchain beyond the hype. And this was kind of a series of 5 different criteria that you'd want to look for to ask whether a use case merits being done as a blockchain or should simply be done as a centralized service, kind of like an Uber, right? So one of them would be a shared repository of information used by multiple parties, multiple writers to that ledger, who are kind of more like peers to each other rather than one kind of at the center, where there's a minimal amount of trust between the parties involved, where right now there's generally an intermediary or a central gatekeeper that's being used to try to enforce that trust. And where there's dependencies upon transactions. Now, I didn't really talk about this when I gave the example of writing to a blockchain, I have a clicker in my hand, or here's a cup of water. But imagine I'm writing a transaction to a ledger that says, I'm giving Jesse my clicker. Yeah, take it, that's fine. Don't click anything though. And now there's this entry in the ledger that says I've given a clicker to Jesse. Now, if I try to give that same clicker to my wife, Kate, the network would reject it. Because the network says, no, you've already given that to Jesse. You don't have the clicker anymore. Only Jesse can hand that clicker off to anybody else, right? So this series of dependencies in the entries in the ledger is also a critical part, yeah, thank you, about how these networks work. So this is kind of a rubric that you can use. Another kind of way to divide up the space here is to think about 2 different dimensions to how these networks work. One of those is permissioned versus unpermissioned, which I kind of mentioned is kind of like, is there a bouncer at the door, right? Letting parties in, kind of defining what the rules are between folks, what the technical rules are, but also the legal agreements between parties. And then how visible is that network? Is it visible to the public, or is it visible only to that private group? And there are examples I'll give of public permission networks in just a bit. So one example, so they say diamonds are a blockchainer's best friend, and I use this example a lot, so apologies if you've heard this, but the diamond industry has now 2.5, 3 years into using a blockchain to track the flow of diamonds through the industry. This is an implementation of a process that, a treaty actually, well not a treaty, it was a business agreement between the participants in the diamond industry called the Kimberley process that built a tracking tracking mechanism for diamonds through the system to try to keep blood diamonds out of the retail network, right? And diamonds that had been used in war zones and to pay for weapons and that sort of thing. And previously to this system had been implemented using fax machines that were faxing documents that were attached to each diamond. As the diamond would change hands from one party to the next, there was a piece of paper with stamps on it, and that piece of paper would get faxed, essentially a copy of it sent to a central repository in Antwerp, through which, if you did care enough, you could take that piece of paper and say, does this piece of paper match the history of that piece of paper operated by going to that company, that nonprofit in Antwerp, paying, I think it was a large amount of money, and getting that attestation. But you really didn't know, looking at that statement, what those stamps meant, what those signatures meant, et cetera. So this was a pretty poor system, even though it had the right intent. When they moved to the blockchain, and this has now been in production for the last year, the idea here is that everybody who deals with these diamonds, who pulls them out of the ground, who hands them to a distributor or to transport it, to set it into rings, and then finally to get it to the retail network, writes an entry to a shared ledger between all of the different participants. And what's written to that ledger is metadata, data about the diamond, its shape, its color, its size. In some cases, they can now put a serial number directly onto the diamond that you can see by a microscope, but doesn't affect the color or quality of it. And there's other techniques that are coming around too. And then whenever somebody receives it, they write the other side of that transaction. I've received it, it does match these characteristics, and this looks good. And so when you receive this diamond at any point in this, you can see in that ledger the history of what's been written and who wrote it, and the signatures left by the people who wrote it. And that history cannot be corrupted, it cannot be changed. And remember how I mentioned this concept of prevention of double spend? Well, this keeps a middle person from being able to send the same product to two different parties, right? Which would be a way for them to slip in diamonds from the Congo or something like that. This has been in production now for about a year. It's already processed millions of different diamonds through the system, and has blocked millions of dollars worth of attempts at fraud, which they are very politically kind, and they say is missing paperwork, but really, you talk to the people involved in the project, and they say, yes, we've kept millions of dollars worth of attempts at putting fraudulent diamonds into the market. So that's pretty cool. The fishing industry now is pursuing a similar approach. And in fish, you have a similar situation where you have fish caught in regions that are acceptable, right? Where there's various treaties that correlate to different species of fish, where they allow it to be caught, so as to protect fisheries, and so as to protect the long-term fishing stock. So every legit fisherman has an interest in participating in this system, an intrinsic interest, as well as the processors, because it helps preserve the long-term viability of their industry. And so this is not in operation yet, but it's being built. It's the same kind of idea. Here's a load coming off a boat. Here's a load that's being, processed fish now that came from this source. Here's now it going into the market, that sort of thing. So that when you go to Whole Foods and something says sustainably caught, you should be able to have much higher confidence that there's actually something of substance behind that, right? And this matters not just to the consumer at Whole Foods. This matters to countries now that are starting to try to keep pirate fish stocks, basically, from entering the country in the first place, right? And without a traceability system like this, you don't really get anything of value. You can't really attest to the integrity of that system. Now, what's different about this than diamonds is that it tries to address a problem that Sheila Warren at the World Economic Forum coined, which I love, which is, most technologies have a garbage in, garbage out kind of problem. Well, blockchains have a garbage in, garbage forever problem. And there's nothing magical about this system that means that when you write something to it, that it's true, right? It could be completely bogus. Well, so in addition to trying to write, this boat came in to port and it unloaded its catch of fish that were caught at this time in this region, well, how do you really know that's true? So in addition to that ordinary data, what's also written is sensor data from buoys floating out in the water, from sensors on the nets. There are these tamper-proof GPS sensing and weight sensing sensors for nets that now can take that data and record it into a blockchain, as well as information from sensors during the shipping process as well that measure not only GPS but also temperature, so that hey, this was safely transported. This didn't sit in a container at 100 degrees Fahrenheit for a week, right? So all of this is used as extra data written to the same ledger as the tracing data so that somebody can try to draw the connection here. And it might be possible for one piece of, for one shipment of fraudulent fish to come in, or from one package while it's in transit to be swapped out for another. But by collecting like a chain of evidence of this, you'd hope to catch the large violations that would happen out there, the systematic violations, because you could then apply modern techniques of machine learning and data science and such to what should be a much higher quality data set than average. There's not a lot of time left, so I won't go deeply into this, but this is another deployment of blockchain technology in production today, which is a global trade finance network that has been set up between HSBC, Deutsche Bank, Santander, and about 10 other banks to manage the entire trade finance process from letter of credit all the way to final receipt of goods. And this has not seen a high volume of traffic. I think they've processed 7 or 8 transactions on this network in the last few weeks that they've been live. But the goal here is to standardize and routinize a whole lot of processes that are either point-to-point or performed by overworked back office staffs, by ledgers that go out of sync with each other and require a lot of manual kind of intervention to try to correct, and to hopefully get the entire process of applying for trade finance, for export credits, and then processing it all the way through and finally getting paid to be much more optimized than it is before. So this is a pretty exciting project. And just like with the others, there are entities that act as conveners of this network, but they don't centrally hold the data in any way. What the data is held on the ledger and shared between the different parties. I have a final big idea, which I really don't have the time for, but blockchain technology is also going to be critical to, I believe, getting us out of the mainframe style centralized identity management stuff that we have going on the internet now, where instead of you being defined as log into Facebook, log in with Facebook, log in with Twitter, instead being able to store your personal data as well as attestations about you, claims made about you, things like your birth certificate, your diploma, your healthcare records, your financial records, being able to exist as data you can hold close to you and something that looks and feels like a wallet, but then you keep track of using a blockchain, who that's shared with, when it was shared, and being able to withdraw consent for the sharing of that data. So how many of you here know what the GDPR is? Okay, for many of you, it's perhaps been a pain in the ass in the last few months. It certainly probably meant a lot of emails and click-throughs and kind of a questionable, is this actually going to have an effect? Well, the intent behind GDPR is to give you agency over your data. And there are people who've been working on the tooling to support that kind of concept, the ability to not only share and keep in mind who you shared it with, but be able to pull that back, or even just keep the company you shared it with from sharing it on to somebody else. So there are a number of projects out there, including one at Hyperledger called Hyperledger Indy, which are building infrastructure for tracking that sharing of data and the consents and the withdrawal of that consent. And ironically, blockchains, which are all about sharing data amongst everybody in the room, right, amongst everybody on the network, is the perfect way actually to keep to allow us to get to a world where we're actually minimizing the amount of personal data that we have to be that we share or feel like we have to share. So, in my take, the long view of this stuff, and you could ask whether it's 10 years or 5 years or 20, it's really hard to tell. I swear I was there at Wired one point saying, yeah, eventually everything's going to be online, but you wouldn't do something crazy like buy a car on the internet or anything like that. So my efforts at long-term prognostication, especially witnessed by not buying Bitcoin early, don't necessarily take as gospel, but I'll just try to read these real quick. So consortia forming these kinds of blockchain networks, these governing entities that shepherd each of these ledgers, that'll become pretty routine. Right now, it's pretty ad hoc and bespoke, and we don't really know how to form these things. There's a few of them out there, but we're going to get really good at that, I think, and have a couple of templates for how either existing organizations that act as kind of consortia in the business world either take that role on, or brand new consortia, brand new for-profit companies step in to perform that role. I do think most multi-sided marketplaces become blockchain networks, right? That could even mean something like ride-hailing, for example, right? It could mean something like eBay, right? Becomes a decentralized kind of a system using blockchain technologies. It's really hard to get that decentralized to the point of average end users standing up a full node themselves, but I think we'll find ways for entities that can act as the agents of the users to form these ledgers. I think most bureaucratic processes, whether it's like starting a business or getting a birth certificate or diploma or selling a house or a car, will become blockchain based because it just makes more sense for that kind of data to be stored collectively or communally or tracked collectively rather than being stored up and only defined by what's in, say, a government database, right? Like your driver's license should be something that you have physical possession of in a digital way rather than just an entry in a database in a California government web computer, right? Or a cloud somewhere where that ephemerality means it actually could disappear at any point. And so this is about building a much more resilient, I think, system when it comes to managing that kind of thing. And then finally, I think the reason I'm in this is not just because enterprises are cool and the Linux Foundation is cool. We have a serious war on truth, right? And it didn't start in 2016, although we felt it really sharply then, and we still feel it sharply. But it shouldn't be as hard as it is for us as communities at all sorts of different scales to come to a common ground truth about the world, right? To agree on a set of facts, to agree on what happened on July 4th, 1776, right? And we actually, it used to be that if an event was published in the newspapers of the world, we had microfiche copies of those newspapers. We could go back and see, what happened, maybe not July 4th, 1776, but you could see what happened on a certain date in 1923 and how that was reported. The digital world is still, despite the best efforts of folks at the Internet Archive and elsewhere, still too ephemeral to necessarily trust really vital stuff like this too. And so there's a lot of people who believe by super distribution of a lot of this information, by essentially all of us acting as notaries on everyone else's transactions, right? We can get much more quickly to a common ground truth for things. And maybe that means technology reclaims its role as a tool of liberation and justice, but who knows?
One of the things I want to start with is, there's a lot of excitement. We understand how blockchain as a technology works, and you're building new tools for it. But let's talk about the dependencies for some of these use cases. So let's look at the sustainable seafood case, and tell us what are the pieces of that, and do they exist now? Are they out there and deployed? Do we have, IoT in the seas that's validating that where these things are coming from? What's that ecosystem, if you will, of technology, and how much of those things are in place, and how much is almost there, and how much are further off? Can you give us a sense of some of those things?
I don't think it's a hardware problem. I think there are devices now that are available off the shelf to be able to do the kinds of stuff I mentioned. There's a company called Smart Catch that makes these net sensors, actually. That they even have video cameras on them, so you can see the kind of fish that you caught. It's kind of crazy. There are these sensors on buoys and at ports and things like that to collect that data. That's real. The blockchain side of that picture is really simple. It's, you stand up a network of nodes, and this is what Hyperledger has built. This stuff is in production now. That chain is not in production yet. That's still being developed. Intel is one of the leads on that. But they have gone to a number of the different fish processors and some of the major fleet operators, all of whom are what they're trying to prevent are the renegade fishermen who actually offload their catches to legit fishermen in weird waters, right? Who then come back into port and try to offload. So I'd say probably the biggest challenge will be getting a critical mass of the participants in any marketplace at enough layers in the chain from beginning to end to start working together so that they basically by working well, shame the rest into joining that network. And maybe it even means if you're not part of that network, you can't sell your fish not only to Whole Foods, but maybe not even to any retailer in the United States, right? So I think there's a bootstrapping problem with a lot of these networks.
And just to look at it a little bit more closely, so it's starting with at the fisher level to the merchant level is the end point. Along the way, there are transportation legs that are there. There may be the port itself that needs to have some infrastructure there. And are you seeing that, or does it look like it would be something along the lines, it's like the Good Housekeeping seal, that this is like certified? How does that, I mean, do you, and again, this isn't obviously your piece of it, but I'm curious what you're hearing because you're talking to, I mean, in your role, I think you are encountering every piece of the ecosystem of folks that are touching this stuff. Is it that I would have an app and I would be able to see that this fish was and verified it myself, or that the merchant is providing that certainty at that level?
This is still predominantly a business-to-business technology, right? And it should be the case that there'll be eventually providers who act as a kind of a portal for average consumers to be able, so that, you know, in theory, Whole Foods should be able to provide you some sort of app that says, where did my fish come from, that surface the data back to that chain. You still have to trust that Whole Foods is telling you the truth, right? So that, you know, but it could be at some point that that ledger becomes fully public and there's multiple ways to get to it and verify it. An example of an application I'd really like to see that looks more like that would be voter registration rolls. So a lot of people talk about, hey, should we use the blockchain to help manage elections? And I think it's a terrible idea to cast votes using a blockchain because it's really hard to simultaneously preserve the integrity of the election and the confidentiality of voters while being able to audit it. But you could use a distributed ledger for the voter registration side of it so that everyone's looking at the same database with regards to who's registered to vote where. And you could use it at the tail end too, which is what's the summary from each of the different locations, right? Each of the different polling places, and then rolling that up to kind of a state level or global kind of, or national summary for how the vote went, right? And in both those cases, having the public be able to see that ledger, each individual item, right? The entire spreadsheet, so to speak, is essential to building trust and confidence in the process. And so for that, I would fight for that to be very public. For something like diamonds, you know, the participants in that market have already gone through this complex political balancing act of sharing just enough information that they can audit each other on where these diamonds came from, but not sharing things like the prices they paid, right? And other metadata that could be used by investors, perhaps, to short stocks of companies that they think might not be doing well, right? So I'm a very pro open data kind of guy and transparency kind of guy, but for a lot of good reasons, the business communities are only willing to share data if it means they can't get access to other things, right? And in the case of the diamond industry, there was a mandate from the policymakers to clean up their act when it came to blood diamonds and that sort of thing. And that kind of pressure is essential in a lot of these chains. I think these chains are a way to finally get things that economists consider externalities in markets finally reintegrated into the flow of goods and commerce. And, you know, whether that's labor conditions or carbon credit, you know, carbon load, for example, of the different products flowing through, or you know, other things correlating to the Sustainable Development Goals. So that's the idealist in me, and that's kind of why I'm involved in this. And you've got to have it create just enough economic value, business value for the businesses to pick it up and use it, because they won't do that just endogenously. They need some business problem that they can solve at the same time.
So I know we're going to get a lot of great questions about blockchain. I want to take a kind of half step back and talk about open source for a second, because and let's on that theme around ancestors. So I think that accounting methods start around 7,000 years ago. To go all the way back, and then it's like 1200 or something is when double entry, I think, started. So then closer to, we said the web, you know, as we're approaching quickly, was 30 years ago. It was 20 years ago, I believe, that the open source initiative came together. So can you talk about where open source was when you started with, when Apache was starting, not to go too deep into it, but just to give us sort of a flavor, because we're in a very different moment now where it's not as individual driven, but you know, you're working with a lot of corporations on open source projects, and that's, I can't imagine that 1996 Brian would have imagined that would be the case. So I don't know, what was your vision of where open source would go in the late 90s?
Right. So I started as freshmen at Berkeley in '91, and pretty much immediately found the internet. Kind of fell into the same rabbit hole that I think a lot of other people fell into at the time, where it's like it's so much more engaging than what I was learning in my classes, right? But a lot of what I was learning was about how internet architecture came from people voluntarily working together and not just saying, "Hey, this is how things ought to be built," but actually building them and releasing that code and doing it out of an academic interest, but simultaneously, it's not a very good demo if it doesn't work. So let's make this production quality code at the same time. And the easiest way to do that was to publish the source code in addition to the software so that other people could help you find your bugs. I fundamentally really resonated with the idea of put it out there, let other people hammer it and tell you where you're wrong, and be able to recover from that and evolve. And that's where internet email came from. That's where DNS came from. That's where Gopher and FTP and IRC came from, was people sharing this code pretty freely. And so when the web came along, what did Tim Berners-Lee do? He didn't start Web Inc. and release a proprietary web browser and server. He released the source code to the Next client and his web server that he wrote that also ran on Next, right? And then other people started also writing open source. We didn't even have that word until '98, but free software, you want to call it that, shareable code. And so it almost felt sacrilegious to start a proprietary web company at the time, although when Netscape got started, that was great. But Apache felt like it was just continuing, it was the next iteration of a pretty logical sequence that came before. And there wasn't a sense that it was anti-corporate. I mean, I did propose the name Apache because I wanted association kind of on a romantic side with the Apache tribe, were the last tribe of Native Americans to surrender to the United States. And they paid a very heavy penalty for that. If anyone's been to the Apache tribe areas in Arizona, they definitely are not as well off as some of the other tribes out there. And so I kind of felt like, as a joke, we'd be the last one standing before Microsoft took over the web. They owned the desktop at the time, so we thought that made sense.
And you had started what became known as the Apache project, correct? And then how large was the group by the time you formalized that?
9 of us initially, and then that became, I don't even remember, but about 1990, by 97, it was clear that it was on 60% of the websites at the time, and which it was one of the few pieces of software you could actually measure how many people were using it, because you could ask a web server at any IP address, what server are you running? And so this great place called Netcraft started doing these monthly surveys, and so you get this gorgeous chart of the rise and fall of Apache's kind of trailed off.
Because Apache was at the top of it.
Yeah, admittedly, sorry. But it was very measurable. And so when that happened, I think '97 was when we first started fielding inquiries from companies. Well, asking where they can send a purchase order for Apache 2, and we're like, no, it's free, and they're like, well, I don't know if our lawyers will let us use this. And like, no, not really. We're not coming after you. But then it took a couple people warning us about things like patents. If a patent holder felt that we had implemented something that covered one of their claims, as individuals, we could be sued for our livelihoods and for our nest eggs and things like that. And then it took a couple of large companies, including IBM, kind of stepping in and saying, well, there might be ways to shield yourselves from that liability by incorporating. And a couple of other people had said that as well. And we also felt then like none of us wanted to be web server developers for the long term or even full time. And yet we felt like what we had come up with in terms of how we worked, which was very decentralized, very virtual, could be replicated, right? And so that was so by '98, we had launched the Apache Software Foundation, but that was with a lot of help from a couple of corporations who provided pro bono legal services. IBM, as well as the company I co-founded, Organic, spent a lot on legal help to make that happen, and branding and that sort of thing, right? But we did. We created this 501c3 nonprofit that has served as a home, and now there are many of these other organizations that have spawned, other software foundations, et cetera, and all of them designed to provide both the legal shield for the developers, as well as just enough structure and formation to be able to allow the devs to contribute and collaborate without taking on a tremendous amount of either personal liability or long-term maintenance unless they wanted to be involved in that.
And at that time, you guys are all, I assume, your guys in your 20s, and then cut to today. So Hyperledger is a project of the Linux Foundation.
Right.
Characterize the Linux Foundation for a second.
So the Linux Foundation is a 501c6, so a different kind of nonprofit, but it's more of an industry consortium, funded by membership dues of over 1,000 different companies now. And within the Linux Foundation, there are a number of funded projects. So there's the Linux kernel and a bunch of things that are directly related to the operating system. But there's another project called the Cloud Native Compute Foundation, which is the home for Kubernetes and all this other containerization work going on. There's a set of projects related to how telcos use software in managing telco routing infrastructure. And then a couple of security-related ones and Hyperledger. And the idea then is companies pay to be a member of the foundation. They also pay a little bit more to be a member of these funded projects. And then they serve as a constituency of sorts. They have a board, so I have 25 different bosses. I've got a governing board of a couple of the major companies involved there, as well as my own boss, Jim Zemlin, who's the executive director. But we essentially have our own budget. Then we can decide how do we spend that to act as air traffic control for this software developer community. We don't write the code ourselves. We don't pay for that code to be written. That software development has to come from the community. That's a way of validating that what's being built is actually what's needed by the community, not just what I think personally should be built, right? Because I'm not going to have nearly the good ideas that I think others in the community will have about what should be built, and that's done often by large companies, but also by startups, also by students in some cases, by people out there who want to build the next layer of plumbing for these kinds of distributed applications.
All right, we're going to get your questions going here. I think we've got one right there.
Yes, you mentioned that metadata can be associated with transactions to be able to identify fraudulent transactions after the fact. So to what extent do these platforms support using that metadata in an automatic as opposed to manual way to go way back in the ledger and correct transactions?
Well, you get a full copy of the ledger, and the simplistic model, right, is you get a full copy of the ledger at every node. And you could certainly modify your own copy of the ledger if you want, but you can't, there's really no practical way for you to hack into everybody's system and change everyone's old entry, right? Nor is there even a way, even if everyone agreed, if you changed an old entry, then the signatures don't match, right? And so generally speaking, you don't do that. You put some new entry into that ledger that corrects for what was written in the old one, right? But that's just about changing entries in the ledger. Obviously, this presents an issue when you run into regulations like the right to be forgotten, right? Or you wrote some other personally identifiable information into the ledger and want to purge it for some other reason. And so for that, you actually, there's some types of data you don't want to write to these ledgers. You want to be able to delete them, but you can keep a pointer to that and a signature of that so you can validate that that is actually the data associated with that entry in the ledger. And then when it comes to your metadata question, I'm not sure how to answer that.
I think you got it.
Okay, thanks.
Here you go. Stuart?
Hi, Stuart Brand. Is there an accumulation problem? Mm-hmm. As soon as you said garbage in, garbage forever, I thought, well, is it a situation of infinite data in, garbage forever? How does the system collect its garbage in a sense?
Right. So I just bought a 4 terabyte hard drive, portable hard drive for $150, right? And something on the scale of the Visa network is 20,000 transactions per second, which would generate a couple of gigabytes a day if you boiled it down to just the account numbers and the quantity, right? No one should think of blockchain technology as a big data tool. You really want to optimize it for numbers, for capacity, right? Which means actually writing as little data to it as you can get away with. You want to be very concise in describing it because it's what you want everybody to have copied everywhere. So I think that is one thing that serves as a natural constraint. But otherwise, when it comes to the history of the ledger, there'll be approaches to dealing with that amount of data. You could simply say, okay, the world state, as it's called, the state of the ledger as of at the end of every year is basically, it's reset. You can take that old series of entries, archive them somewhere. People can keep copies of that archive somewhere, and you say, okay, we're starting with a new Genesis block, as they call it, where everybody's balances or everybody's assets are distributed this way, and then move forward from there. You may even decide, hey, we can throw all this away because it happened 20 years ago and we don't care, or it's beyond the statute of limitations for something, right, or something like that. But generally speaking, I think in many of these cases, the storage isn't going to be a problem. I think we now know how to store an arbitrary amount of data at every node for a pretty affordable amount of money. I think the bigger question will be transactions per second and throughput, and that'll be the bigger limiter. Because getting an entire room of nodes to agree on what the next entry in the ledger is going to be is still the rate limiting step. We consider it lucky when we get to 5,000 transactions per second on a given node. So I think those will be the constraints that introduce themselves to.
And along those lines, is there any vulnerabilities or anything akin to like a DDoS attack are there and related to that, are there learnings that are getting shared as problems and so forth come up? How are those getting shared across community of technology?
So this is another place where there's a big difference between the permissioned and unpermissioned networks, right? In a permissioned network, again, like people in this room, if all of you started yelling out questions at the same time, he'd call an end to the event pretty quickly, right? Or some other governance mechanism would kick in, and right.
That's what happens after we turn off the mics.
Exactly.
Then everybody yells. We want that.
But in a room without a bouncer, right, in an unpermissioned network, you do need other tools to be able to prevent against bad actors, right? And so this is really the field of crypto economics, as it's been kind of called, right? It's one very arguably plausible reason why you might actually want to have transaction fees at the heart of some of your larger networks, so that if somebody did want to spam it, they have to spend a lot of money to spam it, right? I think the larger the network gets, the more likely it is to have to require those kinds of mechanisms. At small scales of 10 to 100 nodes, you might simply have a convention that says, right, you're allowed to write at a certain rate, or you're allowed to fill so much capacity, and if you go above that on a regular basis or attempt to attack the network, you're booted out of the network. The metaphor I've been using for the organization that would act as a governing entity has been a referee on a football field, right? Which not only gets across, there's a sort of, law enforcement kind of role, but if they end up doing a bad job or abusing their position, if they charge players $100 to come onto the field, right, they will get fired. And so in the design of these blockchain networks, it hasn't really come up yet, but I think as they mature, a big question will be, how do you fire the ref? How do you fork when the governing entity gets too much power, essentially? And that's going to be another interesting evolution of these networks.
Brian, you talked about consortia formation and the importance of consortia formation. And it feels like, to a degree, the prediction you made is already coming to fruition, that consortia are becoming easier to build, and we're having more and more people solidifying around projects. But it feels like right now they are, to some degree, empty consortia. That they've come together, they have a notion, but there aren't that many transactions. We're not really in the production phase. Mm-hmm. And if you were a cynic, and certainly I'm not, but you might say that people were doing this to issue press releases. And so I guess what I would ask is, when the technology alone is insufficient to drive us to production, what are the other critical factors that need to be in place for us to get over that hump and actually start putting all the fish on the blockchain and all the diamonds on the blockchain and really be, operating at the level that the internet does today? How do we get blockchain from this test stage to the production stage?
Well, in the early days of the internet, of the web, it was rife with websites launched as press releases, where many of the first websites were literally, and I know because this was what organic did for a long time, take a paper brochure, scan it in, turn it into HTML, and put it up, right? Where interactivity and being web native was it took a while to come along, right? There was a lot of, not only hype, but optimism and build it and they'll come kind of field of dreams kind of stuff that happened then. And I think That's got to be a recurring pattern in technology movements, right? I don't know that people are being irrational in thinking that someday this will pay off. It's really a question of bootstrapping, right? And I don't think you bootstrap with 40% of a marketplace jumping on board, instantly, right? I think you need the first 10 transactions and then the first 100 transactions, right, to bear out before it'll actually happen. I think Sergey Brin had said he doesn't want to be the first space tourist, but he'll be the 1,000th space tourist because the first 999 will shake out the bugs in the system, right? I kind of agree with that. And I think likewise, no one wants to be the first. It's like, who is the first fax machine, right? Kind of joke. And so I think that bootstrapping problem will hit, and that's why some industries will pick it up sooner, like trade finance, and even healthcare, which is not normally an early adopter of these technologies, but where there's some easy wins in that. But even within a given sector, like healthcare records may take forever to get there, right? Whereas certifications of doctors and where they're allowed to practice is a much easier thing to solve with this. So I don't know. I think across different sectors we'll simply see different rates of pickup, and it's going to take early wins, and not based on ROI, but based on we did this, and we can see a straight line to eventually it paying off.
I'm stuck with the lonely guy with the first fax machine, calling his friends to see if they've gotten one yet.
So I sold faxes in college. It was a real lot of fun. There are two aspects that you touched on a little bit that I think are kind of rife for disruption and, for lack of a better term. One is democracy and one's education. So in both of these cases we have, if you're in the 49%, you're screwed basically in democracy if you have one person, one vote. And can these technologies address that? And similarly in education, if you went to Stanford or Harvard, everybody just looks at that one word and you're done. Everybody else has to prove what they've done, to prove, Khan Academy and every other step they've ever taken. So do you see in those, kind of key aspects of our identity, do you see blockchain changing how we relate to each other?
I can't promise that it'll make the world more fair. And nor can I promise, obviously, that it makes the world more willing to look at those facts and make judgments based on them, right? That's a big problem, right? I do hope that it can make the world more auditable. And what by that I mean, like, that the business processes that end up getting modeled into using blockchain technology end up having a physics to them that prevent, wherever they can, fraudulent transactions from being recorded in the first place. Because I think, look, the injustice that I feel exists in society most strongly are people who think the laws don't apply to them, right? Who cut corners, who don't, it just feels like that there's the way that the world should work, and then there's a lot of wormholes through that people have found ways to take and not have to pay a penalty for, right?
The president, for example?
I don't necessarily, right? But yeah. But if we can use this tech to make the world more auditable, more just by the way that it works, right? To try to keep bad actors from being able to do things in the first place, right? Or if they exist, for a pattern to be established and for them to be much more incented to stop the behaviors that today they can get away with, then that feels pretty good to me. Now, we still have to have a conversation about how we come up with those rules in the first place, right? That's still hard work, and this totally could go in a Black Mirror dystopian kind of direction too. At least we should be conscious about that, whereas I feel like in the early days of the web, we felt that greater interconnectivity was an unalloyed good. I maybe we're more mature about that now, I don't know, but I kind of hope so.
So we have to deal with. Let's go back to Mercury. Let's go back to the big energy consumption problem around Bitcoin and around proof of work specifically. That's not an ideal design from where we stand from a climate standpoint now. So how do you think about that? Are there things that you see that are out there now, whether they are theoretical or starting to happen? Are there things that with the work that you're doing specifically that you are looking at any of these things, or do you think it's a little ways off before we can improve on that situation?
It is right now the best technology for taking a network of complete unknowns who have no relationship to each other, nor any kind of legal relationship with each other or commitment to each other, to be able to build a distributed application. I have to admit that, right? Like Bitcoin and Ethereum have grown to a certain scale, and it's not clear like what problem they're solving, but it is clear that they've been able to build something that has a lot of users and a lot of wealth being transferred across that network, right?
And just
so to give it its due credit, and there hasn't been an alternative consensus mechanism yet that has stood up to the test of handling those kinds of loads. There are a lot of determined people in the Ethereum community hoping to get to something different called proof of stake, where basically instead of one CPU cycle, one vote, you have one token, one vote. So, which kind of you could describe as those who have money get to vote on who gets more money, you know, which also doesn't feel great, you know. It might introduce its own negative externalities, but it's at least an alternative that doesn't consume that amount of power. And there are probably some ways to keep that balance of that concerns about overconcentration of wealth and power in that network to a minimum. But it's still unsolved. And I think even if Ethereum does make that leap from one consensus mechanism to another, I don't think Bitcoin will, because too much of the Bitcoin mining community is firmly attached to proof of work and would consider a waste of the capital investment that they've made to transfer. So I suspect it'll have problems if it doesn't find a way to switch over at some point.
All right. Do we have one more in the audience? There we go.
Yes, hi. Okay. Am I on?
Yeah.
Okay, good. So, Brian, I'm a great fan of open source and therefore a great fan of Linux and the idea of Hyperledger. And I'm wondering, if I look at the various use cases of Hyperledger and the various partners that have been brought on, you know, I see a lot of the IBMs of the world, and I'm wondering how you navigate that.
Hopefully you're only seeing one IBM on that list because they only have paid their dues once. But you're right. There's also Oracle and SAP and kind of this old guard. There's also a lot of startups.
They all have revenue models.
There's like an Airbus and a Daimler there, and then there's Chinese startups with unpronounceable names that are doing interesting things in energy and healthcare. The Beijing Genomics Institute, BGI, which is, if there's any one place that is most likely to be Jurassic Park, I went and visited this place outside Shenzhen, where they have like a woolly mammoth statue out front because they're part of that project, right? So it's a pretty broad-based kind of thing, affecting a lot of industries. And to IBM's credit, they've said this is, right next to AI, are two big Hail Mary passes for IBM's future. They've put on the order of 40 FTEs to writing software all day, and as soon as they write it, it gets checked into a public repository. I think they've said 400 or so. They've signed 400 deals with customers to do pilots and production systems and that sort of thing. So do credit for them. They've got an advance over a lot of the other companies in this space. But we now have a vendor directory with 60 different companies in it who are building products and services on top of the different technologies built at Hyperledger. So I feel pretty good that it's not going to be something where the wealth accrues to just one player, but it very much is a duocracy. Like in any open source community, it's really the companies that have their developers get involved and build that underlying infrastructure that are best positioned to then reap the benefits of building things on top of that.
All right, and as a last sort of thought, so we call this the foundation of trust and the blockchain future. Zooming forward 20 years, 30 years, give the same Tim Berners-Lee number to this perfect place in technology we're at right now. 30 years from now, don't worry about how it's done, but the goal of trust and certainty in business contracts and so forth is done. Blockchain is executed perfectly, just as always, as technology tends to be. Can you imagine that world for a second for us and tell us what that changes as far as, does it change the way our business relationships work? Is there kind of more cash because we have to do less sort of auditing and following up on things ourselves? How do you sort of see, are there frictions that are removed from certain types of relationships? Give us a couple thoughts about that, just knowing that you'll probably be wrong, as you said before, but just
well, clearly this is not investment advice, because, it's hard for me to separate what I think is likely and what I hope is likely, because I tend to just focus more on what I would hope.
We do
would be
scenarios here, so you
All
could do
right.
two. You could do two scenarios.
All right. Well, what I hope it happens is that it helps us as a society figure out how to create rules for how we live and operate that don't become a joke as soon as they're committed to paper, right? Like the idea now of industry self-regulation is a joke as soon as somebody says it, right? But an industry that gets together and builds a blockchain to trace the flow of diamonds, you're still going to need auditors, you still need inspections, you still need some degree of correction for bad actors, but at least the tracing of the data is there. At least the ground truth can be established in a way that it can't without it. And I hope that leads to, again, more auditable kinds of systems.
Something
projecting 30 years out, does it mean we're less cynical about finding ways to balance economic growth with economic justice? I mean, with like issues around economic justice or around access to what's considered like a healthy lifestyle or true better livelihoods. Things like the Sustainable Development Goals. If we can find ways to weave each of those goals, each of these things are a metric, right? And if we can, and we're only going to get to a metric if we do one of two things: survey, which has a huge amount of error, or self-report. Guess what? North Korea's poverty rate will be, right? Or find ways to wire the systems of the world to trace these externalities so that we get an exact report of how many girls are educated in Pakistan, or what is the carbon load of the Nike shoes that we're wearing, right? Like, there's two ways you could go about it, and if we instrument this into the systems of the world, I think we'll do better.
So, because the way today it works is that regulation gets somebody, whether it's Facebook or an energy company, regulation is a looming thing, and they go, no, it's cool, we're going to self-regulate, we'll take care of it, and then it becomes a much lower improvement.
It's a joke because there's
yeah. But maybe with this kind of thing, there'd be a way for them actually to work together on something that's a more
and have an appropriate role for auditors and for regulators. This isn't about doing away with government, in my opinion, because government still represents the collective interests of the citizens, right? In a way that businesses don't. But it might make it a much fairer way for regulators to be involved, or much less overhead taxing kind of way for parties, regulators to be able to monitor what goes on in markets and look for bad actors and correct.
All right, so that's all the time we have for on stage. Brian's going to stick around. I know you have tons more questions. Please stick around and ask Brian, and keep the conversation going amongst yourselves as well. Let's have one big round of applause for Brian. And as is our tradition, this is a Long Now Challenge coin to thank you for doing it and remind you to seize the millennium. Thanks again. And like I said, please stick around. And one more big round of applause for you. Thanks for sticking around for a little bit later. Thank you.